Nu är ni redo. So,
let's see. Oh, my dear friends, now it's time for the AutoSail project to present. So please take your seats.
Edvin.
Skulle jag hålla?
Håll den på hakan.
Okej. Hallå. Hörs jag bra?
Där, högre upp.
Typ så?
Ja.
Hi, this is the AutoSail project. This is the AutoSail project. Our goal was to make an autonomous sailboat and then make it sail in an 8-figure between 2 points seamlessly. The team members are myself, Edvin Asmussen, Jonathan Fernqvist, Carl Söderlund, Simon Friberg, Oliver Lagelius, and Fredrik Åbrink. The purpose of this project in whole is to compete in the World Robotics Sailing Challenge, as well as to benefit collaboration between 3 universities. Universities are Maladonas University, University of Antacoya, located in Colombia, and the Technological University of Panama. For this iteration of the project, the goal is to prepare a bigger sailboat to be able to compete in next year's competition. So, first, we will go through what makes up an autonomous sailboat and our solution to the problem. Then, we will go through construction and hardware of the boat. Later, we will go through how the boat system works with both its sensors and actuators. In the end, we will summarize what we have achieved. So, to begin with, what makes up an autonomous sailboat? First, there needs to be control of its sails, which are used for propulsion, driving the boat forward. Second, there needs to be control of the rudder, which determines the direction to be steered towards. To control these 2 parts autonomously, the boat needs to know its current state, meaning its current position, its current direction, how its rudder angle are currently set, and how the angle of the rudder and sail are currently set. All this is done through multiple sensors. It then needs to be able to set the angle of both sail and rudder using motors as actuators. When the boat can sense itself, its surroundings, and also control itself, it will need to have some sort of mission. The mission for this project sailboat can be defined as being able to sail according to a planned path. We chose to manually make a path, which is formed as an 8 made up of waypoints. There are several strategies for the control of a sailboat. Our control strategy is quite simplistic in that it simply chooses the next waypoint to travel to and makes a route directly towards it. We also implemented an unmanned surface vehicle line of sight algorithm, which steers towards the point while staying as close to the path as possible. In our case, this means that if the boat is very far away from the path, it prioritizes getting back to the path instead of steering directly towards the goal. This means that it is relatively easy to draw a figure 8 with few waypoints. Our boat also uses a Raspberry Pi as a main computer and several microcontrollers connected to the different sensors and actuators. The system uses ROS2, which is a framework consisting of libraries and tools to build robot applications. It also connects the entire system, handling communication between all devices. So, at the start of the project, what did we have? We had a 4-meter long boat, a mast, and a boom. The mast wasn't made for this specific boat, so a new platform for mounting it needed to be made. We also received a control and sensor system based on ROS2, built by previous year iterations. But it was made for a 1-meter long boat, and as such, much of the system couldn't be transferred to the new boat. We will now go through the construction of the hardware for the boat, and then later we'll go through the system and how it works with its actuators and sensors.
Oops.
Ska vänta.
So for the hardware, we have been designing and constructing a mast foot, a solution for the mast and boom, a solution for the rudder, and the holders for the sensors in waterproof boxes. So as Edwin said, that there was no mast. The mast didn't fit the boat, so but we had to come up with a solution for that. So on the left here you can see just a prototype of just a 3D CAD to see how the mast foot would fit. And on the right side you can see just here on the plate there's the mast foot as it's milled in aluminium. So we have a complete mast and boom solution. The boom will rest on top of the cart and then moved along the rail by a chain powered by a motor. You can see 3 gears where one of them is attached on the motor shaft, this one, and the other 2 is used to tension the chain and guide it onto the T-list. So this one and this one. All of this is placed on top of a large aluminium plate, so it can be taken on and off the boat easy. So all of this is just the entire solution. So for the rail solution, the chain is moving along the green T-list, as you can see here. And there's a mechanical stop on each side of the rail to prevent the cart from falling off. The T-list is attached to a 3D printed rail. And at the bottom of the boat we have a attachment which will have a aluminum rod placed in the hull and will go from the bottom to the top of the boat. This is done to reduce the weight on the boat, as the boat is made of fiberglass. And we also have a rudder solution. It has a stepper motor connected to the rudder, and an attachment for the motor is made, which you can see on both of the pictures. It's just the red thing, and the stepper motor is placed on top. This is the system overview. It is divided into subsystems, where each system is placed inside waterproof boxes. Each sensor has its own microcontroller, and we also have 3D printer holders designed to mount the components. Here are all the boxes. On top we have the main system, which consists of a router and a Raspberry Pi. And down on the left we have a microcontroller and an IMU. And this box is for, This box is for the wind sensor, and it only contains of a ESP. And down to the right we have the GPS box, which consists of a GPS, radio, and a microcontroller. So for the battery box we have a 48.4 volt battery package, which consists of 2 pieces of 6-cell 22 volt LiPo batteries, which will work as the power supply for all the motors.
Yes, so we use the ROS framework to build our boat. ROS is an open source development kit for robotics application. It provides libraries, tools, and capabilities to help develop a robot, and in our case, a boat. It is well documented and easy to use. Edwin, I think, mentioned that ROS handles all the communication in our system. So for the microcontrollers we use a program or framework called MicroROS. It is used on embedded platforms. This is very easy integrated into the main ROS system. All our code is written in C and C++ and Python. So we have 4 sensors in our system. We have an IMU, which is used to find the direction of the boat. We also have a GPS, which we use to find the position. The GPS accuracy from the beginning is quite bad, so we also implemented the real-time kinematic, which improves the performance substantially. We have a wind sensor as well. The wind sensor measures the wind speed and angle relative to the boat. This is used to set sail, set the angle of the sail. And the last sensor is a angle sensor. It's an adaptive angle sensor. It is used to as a feedback for the sail angle. So our system works like this. We gather data from all the sensors, so the GPS, the IMU, the wind sensor, and also the sensor for the sail angle. We then apply filters and make computations, and then we instruct the motors on what angle to set, so we can reach our goal. In the beginning of the project, we had a scope, so this is what we wanted to achieve with our project. So we had five points, I mean 6, sorry. We wanted to mount the current sensor system, including all our sensors. We wanted a GNSS system that uses real-time kinematic. We also wanted actuators and fixtures to control the sail, rudder, and boom. And also a fail-safe system, so in case our system fails, we can manually override and drive the boat to land. And the last thing is a path-following algorithm that Edvin explained. This is to make the boat smart, so to say. In our case, we managed to complete all 6 points except number 5. We do not have a fail-safe system. And it should also be mentioned, we have not tested the boat in water yet, but it works on land, if that is a boat. Any questions? Okay, yes, is that? No questions. In case people are wondering, it's our boat there, so you can have a look at it later and we can show and demonstrate how it works.
Exactly. So you will be standing there after the last presentation and also at the posters indoors. Thank you. So, and now we will have 5 minutes before the very final presentation of today. A very exciting one. So please